Okay, stop the music.
All right. Good afternoon, everyone. Thank you for joining us this afternoon. I'm say afternoon because I'm in East Coast. For those of you who are in San Jose, in the West Coast, is still morning. But thank you all for joining us for this session. So in this session, what we're going to be talking about is the journey that Cisco IT has taken in automating our network across the board. And we'll give you a couple of use cases that we have done in our environment. And Dan and I, first, my name is Jerry Akwala. I'm a network team manager here for the East Coast in hybrid network access, which is our team in Cisco IT. And then it's one of our senior architects in the organization. Go to the next slide. A quick summary of our agenda. So we are going to be covering Catalyst Center automation use cases. The first use case we will start with will be our software upgrade, how we automated our process from when you start to change requests all the way to incident management and all that. And the next use case will be how do we automatically use automation to solve and resolve incidents. After that, we will also incorporate how do we visualize the data using our Splunk platform to ensure that we have visibility, looking at dashboards to make sure that our operation devices are taken care of properly using the data that we have from Splunk. And with that, let's go ahead and get started. So if you don't hear anything else in this entire presentation, this is the core message that I would like for you to take home with you. When managing a large scale of devices, it's critical for you to use automation if you can in your environment, because it's going to make things it's going to make things efficient for you, help you with minimizing downtime and ensure your devices are compliant and boost your operational efficiency. So this is my core message for you today. Okay. Before we get started, I wanted to kind of set the environment for you. So this is a snapshot of the numbers of Cisco IT, how many we support, how many devices we have in our environment, how many routers, how many switches, um, um, access points across the globe, right? So that way you understand just the scale. When I mentioned in the core message, what the scale of the devices we manage. We have to take care of leverage automation. Otherwise, our engineers will be burned out having to support all this environment if we have to deal with it manually. So, what is Atomic Swim? Atomic Swim, it is an addition feature, an addition wrapper on top of the feature that's already available in Catalyst Center. Catalyst Center has a feature called Swim. Swim basically just stands for software image management. Ultimately, what this does, it allows you to, by click of a button, you can upgrade your device. It could be a switch, it could be your gateway, you name it. It allows you to just use GUI to actually do the upgrade. With that, basically, you have to ensure that you are upgrading devices one at a time. But given the magnitude or the number of devices that I just mentioned to you all, how many we support in our environment, the feature works for us, right? It's great. However, it did not necessarily work with our environment in terms of having to do one at a time. We had challenges where our engineers were spending lots of time to set our environments ready to be upgraded. Outside of before you click the button, you have to go through the service management side of creating the CR and having that CR approved, and then create. Once the CR is approved, then you do distribution, then you do activation. So all that time spent was quite a lot. Where we figure it would be easier. There would be a better way for us to actually set this environment to actually do the work for us instead of us having to manually deal with the work ourselves. So Atomic Swim, the way it came about was basically to help us. So essentially, it is an automated workflow that enables us to do upgrade unattended without any human involvement. The human involvement part of it is just to ensure that the upgrade actually goes through and it doesn't fail. If it does fail, then we take care of it, right? Reason for this, as I mentioned, just the similar reasoning earlier, like time spent. We had a lot of time spent with our engineers crafting and preparing the work for the upgrade, and with number of devices that you have to deal with. Also cost saving. We had service managements that we were using that actually all they did was help us with upgrade, right? And with that, cost saving for us was basically, as we taken on this work on our own, we didn't need outside services to actually do this work for us or manage this environment for us, and avoid human error. We all know as engineers, when you are doing upgrades as humans, everything could go right, but there will be times where you may make a mistake, right? That's just human nature. So to avoid all that, Atomic Swim also helps us with that. P-certs, when it comes to security reason, when there are vulnerabilities that are found with versions that on the device that are running, how do we efficiently get our devices upgraded to the latest version that have patches already applied to them instead of running legacy versions, legacy OS versions. Also, this also helps us with when there are new features that are deployed that are available. Our environment being up to date, we get the benefit from having the latest technology, the latest features, the latest functionalities that helps us to ensure our network is up to date and running the latest code. So on this slide basically gives you a breakdown of the modules that we have, the integration that we have for Atomic Swim to work. We have 6 modules here that basically make up Atomic Swim, right? The first one is compliance. Compliance basically a job that runs and check all of our devices to see if they're running the latest code. If they're not running the latest code, it marks them as needs an upgrade, and we use that. Then the change module comes in to schedule a change that needs to happen for that device to be upgraded, and that change basically it goes in, schedules the changes, and the check module is the one that actually just verifies the device, right? Are there any conflicts? Is there already a change scheduled for this device, or does this device have an issue or an incident open with it where we can basically not schedule a change? Because if there's an incident open, it could be a reason somebody might be troubleshooting it, and we'd rather not have that device being upgraded in the middle, right? And the fourth one is distribution. As I mentioned, the process goes. The distribution is basically copying the image. So after the compliance check, you have the compliance goes through, the check is done, the device is up to date, that the device needs an update, but it doesn't have any conflict associated with it. It gets to schedule a distribution change. And that distribution is basically to copy the image, the latest image that we would like to be ready for the device to be installed. And the next one is activation, which then installs that image onto the device. Throughout this process, if there is an issue with either the distribution that's running, it discovers there's a problem with the device, or some kind of issues that did not allow the distribution to go through, we have the incident module, which then will create an incident for our service group to then troubleshoot the device and fix the problem before we can move on to the activation. The same thing will happen also during the activation phase. If there's a problem with the device throughout the installation of the image, it will create an incident automatically for our team to troubleshoot and work on. So it's basically the breakdown of what Atomic Swim actually does in terms of the different modules that we have. So this slide kind of gives you just the flow again. in terms of the steps that it takes. So the first step is the image tagging, right? We have to select an image that we want to install. We have to tag it as golden, which means that's the image that we would like to install to all of our devices. And then our compliance module comes next to run, which runs every 24 hours, right? Across our entire footprint. This is not specific to an environment, an entire footprint. And whichever list of devices that are found, it finds that doesn't have that golden image version already installed, it will mark to all those devices that needing upgrade. Then the next step is creating the distribution and checking if there are any conflicts. Once it goes through that process, if it doesn't see it, then it gets the image ready to be distributed on a device. And the next step it goes through here is the activation, as I mentioned earlier, to get the device basically ready to be installed, that image to be installed on a device. And all our team basically does with this entire workflow is just to monitor the flow to ensure that the devices are being upgraded. And we check the Catalyst Center, or we have different means of checking to ensure the device was upgraded to the latest version. If it wasn't upgraded, what was the reason? And typically the incident creation part is what helps us a lot. If we find conflict or we find issues, we look at the incidents and we troubleshoot. Even the change request will also have details. If the change did not go through, it gives us details as to why there was a failure, and we look into that failure and get it resolved. And then after we resolve the incident, we don't have to do anything else. We just resolve the incident in our ITSM service, ServiceNow, basically. Once the incident is marked as resolved or closed, Atomic Swim checks compliance, runs again for that device, and then puts it on the schedule. So the human involvement here is only if there's a problem, you troubleshoot the problem, you fix it, and then you leave the device and you leave the case in the resolved or closed case, and then you let Atomic Swim do its thing again. So again, we're not having to manually run any of these checks or any of these compliance configurations. Now, the next use case will be automation resolution. So in this one, we leverage Catalyst Center quite a lot on our daily basis. We wanted to look at how do we have ways to actually automatically resolve problems that we are seeing in our environment. Because, as network engineers, you will have set of issues that you recognize that are more often than not, right? And some of these are low-hanging fruit that you can have automation in place to do something for you. You know when the problem, why the problem is happening. You have a way to solve it instead of an engineer spending their time to actually manually run a command or clicking a button. You can let automation do that work for you. So this one again reduces the mean time for us to identify problems, because you can really tell what the issue is and feeding it with the correct information, right? And it helps us with troubleshooting as well, because if you already understand what problem you're dealing with and you collect the correct information, you can feed that to the SDK, to the code to actually do the work that you needed to do, rather than having the engineer spend hours troubleshooting. And so again, this saves us time and saves us money as well in the organization. So this one is one example of how we're solving the problem. So the first step that we'll take with this incident is actually having the automation read the incident via ServiceNow messaging service application. So in this example, we're talking about an access point that's down, right? So the first step is we read the incident and we see that, oh, there's an AP that's down. The next step is the Kafka consumer, which consumes the incident and creates a ServiceNow offering, which it's directed to our service offering, because within our organization. The step 3 is getting the AP name what's that AP that's associated with that incident. And we know which catalyst center where that AP, the controller where that AP is located, and the switch, the WLC is where that device is hosted, right? Then the next step is we know the status. We look at the status. If that device is actually down, what's going on with that device? Why is it down? And we trigger a self-healing mechanism, right? Which could be a command that to run to actually reboot that switch automatically instead of having someone spend time troubleshooting. We already know that one device is down. How do we ensure that the next step is done through automation? So this is that's step number 4. Looking at the devices are reachable, we trigger the self-healing mechanism and we check the status again. So if this action actually goes through and fixes the problem, then the device shows now it's up and running. All we have to do is send another message for that incident to be closed. If this goes through, the action is taken, and we check the status again, and the device is still not up, is still unreachable, then we trigger an action to actually then submit the case to our engineering team to do a further troubleshooting. And I will let Dan carry on to give a little bit more details on how this area works. Then I'll pass it on to you.
Thank you, Jerry. Jerry, if it's okay with you, can I have you just control it? I'll have you switch the slides. I've got to close my WebEx and reopen it to change my security permissions to share my screen for some reason.
No worries, I got you. Yeah.
Awesome. Okay, thank you. So adding on to the workflow that Jerry just discussed around automating incident resolutions, one of the last steps of that workflow, he mentioned that if the automated steps, some of the templates that I'm going to mention that we trigger as part of this automated workflow do not resolve the issue, we open up an incident and get that sent to our highest tier support, our engineers on our team, to be able to investigate and triage the issue further. What's important there, whether automation is going to take care of that incident for us and resolve the incident, or whether we're going to have engineers manually resolve that incident, we want to enrich our incidents with as much data as we possibly can to make that job easier on engineers, essentially put all the information that we can in one single location for them to digest, to be able to resolve the incident or triage it to hopefully root cause the problem. So we utilize the DNA Center SDK to make API calls, and this isn't specific to Catalyst Center. This could, API calls to Meraki, to ICE. These are all things that we utilize, but since we're on the topic of CatC, we'll use that as the example. Here are some of the different Catalyst Center SDK APIs you can see over on the right. The topology, get physical topology, is a function in the SDK that we will call when an incident gets opened up automatically and populate or enrich those incidents with information from these APIs to, again, provide information such as the switch interface information, the status of that interface that the AP is connected to, along with information regarding the management controller for that access point. So the wireless LAN controller, what's the state of the WLC? Is the AP down because potentially the wireless LAN controller itself is down or hard down? So obviously the APs would be down. In that case, that information, will enrich the incident using information that we pull from the API. Anything that you see in the DNAC UI is you're able to essentially pull that information via API as well. So anytime that you click a button or you look at an assurance dashboard in Catalyst Center, that information is available to you in the API. It might be a public API, hopefully. In some cases, they might be private APIs. You can still snip those out using the like Chrome browser toolkit to figure out what those private APIs are. Able to make use of those in some of your custom automations to get some of that data into various different types of destinations outside of Catalyst Center. All right, Jerry, you can go to the next one, please. So here, again, talking about that same automated incident resolution workflow that Jerry touched on, the automating resolutions for APs that are hard down or flapping. This is a very basic example where we utilize two very simple templates as part of this automation. One of the templates up on the top right, essentially all it does is it takes the access point interface, the uplink for that AP, and we push a template to the switch, the uplink switch, to essentially shut no shut to do a hard flap of that access point on the impact or on the switch that the AP is connected to. Additionally, if that doesn't restore the access point, and make that access point join the wireless LAN controller, one of the things that we also do is we run a TDR test. So we actually execute a template to trigger that TDR test, to be able for us to look at the layer 1 connectivity for that AP, because maybe the AP is down. It's not a hardware issue on the AP, but maybe it's a layer 1 hardware issue. Maybe the cable between the patch panel and the access point is faulty. A TDR test allows us to determine that without necessarily having to send local hands out there with a cable scanner to perform that. So again, this is a small example. We use this process for a lot of things outside of just AP flaps. Everything that any iOS XE device that we manage in our network, which is a large, I'd say probably around 90% of our devices that Jerry and our team manages. We saw that screenshot of, it was somewhere around 7,000 routers and I think 15,000 access points, and probably about 7 or so thousand access switches as well. That number might be a little bit smaller. We use Catalyst Center to push any configuration changes to those devices, whether that's through day-end provisioning or when we push feature templates using the template programmer API to be able to do it larger at scale. We have 3 different Catalyst Center clusters, individual clusters for each the America region, EMEA region, APJC region. So it's 3 separate clusters our team has to go into and, click boxes in the UI in order to push configuration changes to thousands of CIs. So whatever we can do to automate that even further, which is exactly what we do by utilizing the DNA Center SDK. In this particular scenario, you can see that config_templates.deploy_templates v2. That's another SDK function, DNAC or Catalyst Center SDK function that's available for us to be able to push templates at scale without having to actually go into the UI and go through the full day-end provisioning workflow. So again, this is a very basic example, very simple templates, but you can get as creative as you'd like for these scenarios. Some of the future use cases that we plan on, that's okay, Jerry, you can stay on this slide. Some of the future use cases that we plan on expanding to: partial collection failures. DNAC needs to be able to manage devices if we want to be able to utilize DNA Center for assurance, for operation support. If we need to push configuration changes to those devices, Catalyst Center has to be able to manage that device. It needs to be in a successfully managed state. So if a device is in a partial collection failure, we could almost expect that maybe some of our automated workflows that we might have, in production might fail because Catalyst Center is not currently able to SSH into the box. If Catalyst Center can SSH into the box and our automated workflow is going to trigger a template or push a template using Catalyst Center, that's not going to work. So it's important for us that, well, how can we get on top of devices that are in partial collection failure? We can automate an inventory API call that allows us to pull all the devices that are currently in a partial collection failure on a cron job, let's say every 24 hours. And based off that list, we can proactively open up incidents or trigger automated workflows to be able to maybe repush a template to the device for SNMP or VTY/CLI related configuration in order to potentially help resolve whatever's causing the SNMP failure or the CLI failure that Catalyst Center may have trying to synchronize with the device, causing a partial collection failure. High availability is another use case that we plan on expanding on and developing some fully orchestrated workflows to resolve high availability issues between like 9800 EWLCs that are in HA, or maybe even AirOS controllers that are in HA. We're phasing out of, we're moving away from AirOS entirely. So we might not spend as much development time solving for that platform, but we'd focus more on the, the iOS XE side of things with the 9800 controllers. Okay, Jerry, next. Thank you. So the next section, I'm going to go through real quick, so I want to make sure that we give Motaz enough time to cover his fantastic content. Jerry, if you don't mind, actually skip through these slides that share the code snippets. We will share these slides out with you all at the end of this session as well as the recording. So you'll be able to go back to those previous slides. They just share some code snippets, some code examples of ways that we perform some of the things that I'm about to talk to you about. Jerry, can you go back one slide, please? And again, AI is your friend in those scenarios. Those code snippets can be easily generated through AI Copilot. Our internal tool we use is called Circuit, similar to Copilot. Those tools can be used to create these code snippets that we shared for you, or that are on those previous slides that you'll be able to check in the PPT that we'll share out. But the important thing here is that we like any of our fully orchestrated workflows or our automation, we want to ensure that all of the logging for that code or any of the data that we pull from APIs from, let's say, Catalyst Center, Cisco Spaces, Meraki, ICE, we funnel all of that data into Splunk for several reasons. One, Catalyst Center does a good job from a historical assurance perspective for up to only 30 days. So you can go and see, the current state of a device and go look back at the last 30 days of historical assurance data to see what issues that device may have experienced or what issues a client may have experienced within that 30-day window. At that point, that data is purged from the assurance database within Catalyst Center. But if we send all of that data to Splunk, which we do, we can ensure that we have visibility into that data for longer than 30 days, really for as long as Catalyst Center's been sending that data. So we can actually go back to 60 days, look at a 60, 90, 180-day window to start to find trends in certain issues that we might be investigating because we're noticing an uptick in the amount of incidents coming, hitting our queue for a particular type of issue or maybe a particular type of network devices. So utilizing Splunk to be able to do big data analytics and trending is very beneficial for us from an IT perspective for both network operations and DevOps. So this slide, essentially, this just kind of shows when you create custom automation, like in our case, the fully orchestrated workflows, Atomic Swim, and the AP flapping automation that Jerry talked about. What we can do is we can essentially utilize those Python scripts to structure that data that we might be pulling from those APIs into either XML or JSON format and send that data very easily into Splunk using a Splunk handler logging function within our code. Again, you can you can use Copilot to be able to figure out really quick and easy how to do that. But once that data is in Splunk, we now have the ability to extract extract that data from those structured formats, and then do things like tabling, visualization of that data either through tables or my favorite, graphs and visual graphs, pie graphs, ways that we can kind of visually see certain trends or even be able to keep track of progress on certain projects. One thing that Jerry touched on earlier that I want to make sure that I called out on this section was he mentioned that the only thing that our engineers need to do in terms of upgrading our devices using Swim at this point, because we've put Atomic Swim into production, the only thing that our engineers need to do is essentially monitor the orchestration. Well, one of the ways that our team does that, because all of the execution logs within the script, we send all of that data to Splunk with from the Atomic Swim code base. So our team actually uses Splunk to do that monitoring. And one of the ways that they do that is, again, by pulling that data from the structured formats that we've sent from our automation, from our code base, extracting that data and then visualizing it either through certain tables, certain dashboards, certain graphs. Jerry, you can go to the next slide for me, please. So this is an example of just kind of what I was mentioning here. This is an example where some of the DevOps work that we needed to do in our team over the last couple months, or really the last year, was we wanted to reduce and burn down the amount of unique VLANs that we had deployed across our 300 plus, Cisco sites that we have across the globe. We had somewhere upwards of, I think it was somewhere around, believe it or not, 800 unique VLANs, SVIs deployed across, our entire fleet. And our goal over the last year is config standardization. We want to get to the point where every device, no matter where it's deployed in our network, has the same, 5 or 6, don't quote the number, but 5 or 6 specific VLANs. That way, there's no tribal knowledge. Our engineers know exactly what configuration should exist on a box, no matter where that box is located. So one of the things that we did is we created some automation to be able to utilize Catalyst Center. And by the way, all of this that I'm about to mention was generated via AI. All the code, the Splunk queries to be able to create these dashboards and visualize this data, all created via AI. The only thing that wasn't created via AI were the slides used to share this information for you all, except I'm sure that we probably could have used AI to do that for us now. So what this is doing is this particular dashboard, the automation for this dashboard was using Catalyst Center APIs to pull interface information from access switches managed by our Catalyst centers. All of our access switches are managed by Catalyst centers for the, by the way. So the automation uses those APIs to pull the interface information that it gives us visibility into all of the logical and physical interfaces. So we have, that's how we have visibility into the SVI, the logical SVIs, into the VLAN information, what VLANs are assigned and configured on each physical interface. That information is available from that interface SDK function from the DNEC SDK. Once we have that information, we now feed it into our Splunk handler to essentially get this data into Splunk, so then we can then dashboard that data and visualize it in the way that we have here. So what this is showing us here is we can see all the lists of the individual VLANs across each individual access switch. And over on the right, we've built into our query some visuals that either tell us whether or not this device is standard or not. Is this device ready? And what that means by that readiness column, is this device ready? Does this device currently have our expected and standard VLANs? And can we go ahead and actually utilize Catalyst Center to push our configuration templates that are set to a specific standard? We can't push these templates to our network devices if they have all of these different unique SVIs, because our templates are set to configure, let's say, VLANs 10, 20, 30, 40. So if a site is actually configured for 60, 70, 80, 90, we go and push our templates, we're gonna wipe the device clean, plug and play it, day end provision it with our templates. That's going to potentially not work in the way that we intended to. So we try to standardize the site first, burn down all of those former VLANs. So we only have the standard ones that we want on our boxes. And Splunk gives us a way to make sure that we can kind of see where we're at currently in the process from a DevOps standpoint. How much progress have we made? And then additionally, you can take this data and visualize it in graphs and stuff, which is what I appreciate. A better way for me to kind of understand data is looking at graphs and such. So Jerry, if you don't mind, let's go to the next slide. Thank you. Here's what we call just a burn down graph. This is our dashboard that kind of shows the information that we just saw on the previous slide, but in a graph perspective. So this is kind of showing us over the course of several months, while our team's been going through and actually burning down these VLANs at these sites, these unique ones, we've seen a significant reduction. By the way, these screenshots are slightly old, so this number is pretty much down to the 5 or 6 that we have standard now. But you can see originally when we started this work, which was around November 11th, 2024, our number was teetering around, was it 620? And we've been able to, over the course of, in this particular graph, this is several days. Within several days, we, as our team was doing that work, we can see that we have a significant decrease in the amount of unique VLANs that are seen in the structured data that we've passed to Splunk from those interface APIs that we're running on those network devices through the Catalyst Center SDK. Here's some additional graphs here that are providing us with how much occupied IP space per VLAN have we actually freed up by burning down and removing these VLANs from our network entirely. And then also giving us, the little graph on the right is kind of showing us, well, is this VLAN number actually going down because we're actually shutting down certain sites? We have sites that we're currently just decommissioning and taking out of production. So is that number, is the number that we see for the SVI count over time decreasing just because of the fact that we're actually decommissioning certain sites? But again, this is just an example of millions of ways that you can utilize Splunk to your advantage. But more importantly, all of this is able to be achieved through the power of APIs. Obviously not the Splunk visualizations here, but being able to get this data into Splunk is nothing more than APIs. So if you see the data in Catalyst Center or the Meraki dashboard or Cisco Spaces or ICE, and that's data that you're interested in, use APIs to pull that data and feed it into Splunk so you can do big data analytics like this for larger than like maybe some of those 30-day time windows that Catalyst Center is restricted to from an assurance perspective. And on that note, Motaz, I think we will pass it over to you.
Thank you. And let me just start sharing. There we go. So, hey everybody. So I'm Montez. I'm an SRE with Cisco IT Cloud Edge team, and today I'll be walking you through our automation journey. Similar to what Dan and Jerry shared, like it was a journey. Like we started from way like manual stuff, legacy stuff that you see everywhere, and we started working our way towards where we're at now, and I'll walk you through how we went through about it. So firstly, I'll talk slightly about Cloud Edge, what is Cloud Edge, and then I'll get into the automation journey. So Cloud Edge basically is our core. So we handle everything in the core of the network. So that like you've got your offices, you've got your colos, you've got your DCs, and you want to connect all of that together. So that's where we come in. Today I'll be focusing on one aspect of our team, which is WAN, and this is because this is where the area where we've seen the most innovation and the most automation that happened over the past few years. So when we started this journey, that was 2019, 2020. Back then, 100% of our WAN infrastructure was legacy WAN. So you've got your ISXE devices, you've got them there, you manage them how you would manage any other device. You've got your cut sheets, you've got people going in, making those changes, so on and so forth. Right now, where we're at is that 90% of our infrastructure is on SD-WAN. And this has been a massive push for us towards standardization, config management, and ease of automation. And I'll walk through this as we progress. And also, just to give you small snippet, when we're talking about our Cisco offices, we've got a range of offices. And for me, when I'm talking from the WAN perspective, I'll be focusing mostly on these two in the middle, where a gold, that's your general business office. And usually we have two ISP links going into that office with two WAN gateways, WAN devices. For redundancy, one was always like an active backup thing. So that was a major driver for us moving to SD-WAN. And also one of the other things is we always had transport differences. So you would have your primary circuit as a point-to-point link, and then your backup as an internet link. And then you would have to completely change the config as you go, and you had to come up with it using the old legacy cut sheets. SD-WAN helped us move into a transport agnostic mode. I'll walk just briefly over the SD-WAN Catalyst Manager, formerly known as vManage, and I'll just show you here. So we've got an orchestration plane, a management plane, a control plane, and a data plane. Just try to remember this one as we progress through. But here, for example, as the data plane, this is our devices. These are our offices. And then here you've got all of the different transports you've got. Here is the brains. The control plane is their brain of the network. And then here in the management plane, I'm going to show you this and we'll walk through the whole UI and how it works, is where we define everything. That's basically our GUI for managing our SD-WAN infrastructure. And the orchestration plane, here represented by the validator, just ensures that this device has the right to exist in this network. So this adds another layer of security to our infrastructure. These are just briefly the main components of our SD-WAN. So you've got your manager, formerly known as vManage. This is the dashboard for all configuration, monitoring, and if you want to do things manually, this is the way you go. And also, this is how you interact with the infrastructure via API. The validator, it orchestrates the initial secure connection across the network devices. It authenticates that device, makes sure that it has the right to be in this network, and that's it. It finishes its role as soon as that device is authenticated. The controller, or the vSmart, this is where all of your control plane happens. So this is where your policies are pushed. This is the routing decisions are made. All of this happens with the controllers. So with this, I'll quickly switch to our lab infrastructure. So this is a lab infrastructure. This is your Catalyst WAN or SD-WAN dashboard. Sorry, it's loading again. But basically, here is what we like started from. This is first time we started doing SD-WAN, moving from the legacy WAN. This is where we started. And I'm not sure how familiar you are with SD-WAN, but it offers something similar to Catalyst Center in terms of the monitoring, in terms of logs, in terms of all of this. However, recently also it started integrating much more with Thousand Eyes, so it would give us things like circuit details. So you would see how your circuits are performing, so on and so forth. So coming back here and having gone through this, I'll briefly go over where we were and where we're at. We started from a very legacy thing, as I said. We started moving bit by bit towards a semi-automated way, where we started automating how we generate the outputs of the cut sheets. And then when SD-WAN came along, when we started using SD-WAN in Cisco IT, we started using the templates, and I'll show you the templates in a second. And where we're at right now is, let's say we have a new deployment. We have a new site that we're changing configs. That's all done via automation. Our engineers just provide the minimal details for the automation, and it takes care of the rest. That's including making the pre-post checks. That's including actually pushing the configs to the boxes and so on. So again, example of a lovely cut sheet that we've all seen probably at some point, where you had all of this and then you had to manually fill this up. Of course, this meant that it's more prone to human error. It's not always going to be up to date, and you're going to always have config divergent in your network. And that's not a good thing. If you're trying to like automate or standardize or do anything, having divergence in the network is never a good sign. So then we started, okay, before SD-WAN again, we started doing, okay, Python scripts to actually get the data and fill this out. I filled this out like with dummy data, but it would do this. And it was great, but it's still not scalable, because then you would have a lot of different things that you have to manage yourself and you have to update yourself. And then we started moving to the vManage templates, or the controller templates. Here, a template, as it stands, is basically, it's a collection of configs. And this simplifies it, because then you can just define it once for a use case. So for example, for the primary on a gold site that I showed you, you can define it once, and then that's it. It's going to apply for all of the golds everywhere. And you can use things like variables. So you can add the variables whenever you want. You can change them when it needs to be changed. However, you ensure that your network has the same standard, whether you're in the UK or you're in the US or India, anywhere. It's got the same standards. Only the things that need to diverge are different. So if, for example, this is a template right here for our primary gateway, and all of these are what we call feature templates. So if you go into the feature templates, they all define many bits and pieces of the configs. Now, where does the automation come in? It comes here, where our engineers can go in, they pick a template, they pick a platform. Currently, we have Catalyst 8300s and the ISR 4451s. They add the device name, the device serial number, and here they add their name just so we keep track of who's doing what. And if the device is changing name due to any standardization, they add it. They click hit, they click run, and that's it. The device gets attached to the template. The bootstrap configs are generated. So if it's a new device, it's gonna just you're going to have this, and all you need to do is just plug a USB flash drive into that device, and it comes up. It connects to the network. You no longer need to do anything. So that reduced our complexity when we were going and like deploying new sites or changing hardware or changing anything. Now that reduced that a lot because you no longer rely on the old unreliable copy paste. So that was the first start. And the way we do this, I'll just walk you through the flowchart very easily. So as I showed you that form, and then we've got a Python script that interacts with the vManage APIs to fetch those template variables. So for example, if we look at a device right there, these are the variables. So, the location, the IP addresses, the system IP, the latitude and longitude, the device name, you name it. Whatever you want to do, you can create it. And also, you can create all of these templates via automation. And this is something that we're trialing right now. So we can add a CI/CD process in our deployment of these new templates. So we ensure that we always have reviews, we always test these out. And this is why, for example, our main approach with SD-WAN is that we have a lab instance, and then a dev instance, and then a stage instance, and then a prod instance. So dev is where basically we do discovery work. So this is it. We're doing discovery work here. Stage is mimicking production. So this is where we refine our processes. Once it's approved in stage, that then gets auto-deployed to production. And if, for example, a device is right now a non-SD-WAN device, so for example, we've got devices in the field that are still not SD-WAN. However, they are SD-WAN capable. So what do? We collect this data, all of the relevant data. So the engineers don't even, here again, as you saw, the engineers don't input the IP addresses. This is pulled via NSO from the devices, and it fills that template, attaches it to the template, generates the bootstrap, copies it to the device, and that's done. That gets converted at the time of the CR. Also, the other thing that we are using, I'll try to go through this very quickly, is software upgrades. So similar to what Dan and Jerry shared, we have our version of Atomic Swim. It's not yet as advanced as Atomic Swim, but it's getting there. We're trying to catch up. But in theory, we're doing the same thing for vManage. We're leveraging our ServiceNow, NSO, vManage, GitHub, and even like Catalyst Center for the pre-post checks all via Python script. So the process or the workflow at a very high level is once we add a new image that's targeted for an upgrade for a particular hardware type in ServiceNow, then we check, okay, has this image been uploaded to vManage or not? This is the only involvement here. This is one of two involvements we need an engineer to actually be involved in. So first thing is, the engineer has to upload that image to vManage or the SD-WAN manager. Once it's there, that's a cron job that checks every 12 hours, and that checks it in the dev and then stage, and then we move to prod. So as I said, 3 instances. Once it's there, it starts to run the pre-checks. And that means not just the pre-checks for the device that's being upgraded, but also for neighboring devices. Because if we're the first point of entry to an office, for example, so if we just limit our scope to the SD-WAN or WAN device at that site, we're not getting the full picture. There might be some southbound implications of that upgrade, and we've seen this before. So it runs pre-checks on the box that's southbound of it, just to ensure that we have connectivity and we have the operational status as it was right before that upgrade. Once that's checked, so we're using our internal circuit, which is our internal GPT, to validate these against the designs that we're using. So we have a design document that tells us the golden state or the baseline state for those checks. And we're now using this to check that, okay, those pre-checks meet this. And if it gives us the go-ahead, then we start with the activation of that new image on the device. And of course, we run the post checks just to ensure that, okay, have we lost any of the functionalities after this software upgrade? Yes, if we have lost anything, then it would move back and downgrade the image straight away. If we haven't, then it keeps running those post checks, firstly in the dev instance for a week. And then if that's done, it submits a PR that, okay, in Git, we've got a CI/CD pipeline that, okay, if this is accepted, one of the senior engineers signs off on the results of the pre-post checks and the certification process that went through this, and then it proceeds to the next step. So then it goes dev, and then it goes stage, and then we've got an order for the device types in production. And we keep repeating this cycle till all of our infrastructure is on that image that we've defined in ServiceNow. Why are we adding the extra complexity of certifying an image for a long time? It's because A, we wanted to standardize our checks across the board. We wanted to make sure that we have an automated way that either if an engineer is doing it, if an automation is doing this upgrade for like it, we have those checks are standardized, and the checks process itself is automated. Second thing is the fact that we took this phased approach of dev, stage, prod gives us a safe environment for testing, whether that's new features or like that come with a software upgrade, or like any potential vulnerabilities that we're seeing or any potential config changes. We can also use our AutoCert automation that's built into auto upgrade for it. And this also allows us to develop more think about the failure scenarios for those new features that we're deploying and start testing them internally and have an automation to do it for us. Because then, as I said, what we're starting to do now is basically make the update in the design document and just pass this to our internal GPT. And then that generates the commands, the API calls that we would need to run for all of this. And then, again, auto upgrade. Why did we think of it? Similar to what Jerry and Dan said. Process standardization. We always have, everyone has their own unique way of doing things. We want to make sure that the process is standardized, it's scrutinized, and we're like it's a collective effort. And we can then not have to spend hours doing the upgrades, because everyone who was ever involved with upgrades knows how tricky they can be. Now we can do round the clock, whenever the time zone is allows us to do this, we can just have the automation run. And then if there's a P-cert out there or a new feature that we want to roll out and that comes with a software upgrade, we can do this much faster. The next step is we like device observability and operations. So as I shared, like vManage gives us the opportunity to monitor things. And everything you can see in this UI right here, whatever it is, whether it's the tunnel status or the applications, even like, so this is something like we've got the quality of experience metrics here. That used to be a separate product. Now it's become built into vManage. That gives you a quality of application. So here, for example, you can see that this is 10 out of 10. And you can see overall for 11 applications, we have 7 good and 4 unknown. All of this, you can get this via API or webhooks. So this is something that we've started operationalizing, and we've been building on top of it. So we started firstly with a polling model. We had we set up a Python script, a cron job basically, that would poll our device, like our vManage, every 10 minutes to check if there are any alerts that were generated. If there is any alert, it would then post it into a WebEx space for an engineer to start doing this. And then we started moving like towards a webhook model. So instead of pull, we just rely on the webhook pushing everything towards our server, which then enriches the data, similar to what Dan and Jerry went through about like data enrichment, getting further data from vManage, and potentially creating an incident. And this is where we're at right now. And if I show you, I'm sorry, I don't know why it went here. If we go here, this is an example, for example, from those webhooks. So this tells us that there's a session that went down, and it tells us the details of that device. What's the color? A color is something that's used within the SD-WAN terminology to denote a type of circuit. So for example, this is a direct internet circuit, like DIA circuit. So we can know that, okay, this has gone down at this exact time. And now we're taking this, as I said, like to open it up incidents and get the engineers working on it. And the next stage we're looking into is similar to Dan and Jerry, where we like start using the automation to actually resolve those incidents and triage those incidents. Another thing also is this is a platform. So like SD-WAN, like similar to everything else, it can go down. It can have issues at some time. You might just want to move your tenant. You want to move anything. There's this Cisco CX tool that basically helps you with this, which helps you backup, restore this. And we have this running on a weekly basis. So we have a weekly backup of all of our vManage. So that includes the template, like the templates, the device, the inventory, everything is backed up weekly. So if we, like, for example, if we take the dev instance, for example, if someone makes a change and completely destroys the vManage, then we can just easily restore this. It's just a script that you can, like, everyone can have access to. It's provided by CX. So we're using this very, very heavily. The next thing is enrichment. So we started looking into like working more and more with Thousand Eyes recently. And that's because while vManage gives us the overlay visibility, which is because everything in SD-WAN is IPsec tunnels. So all the traffic goes into IPsec tunnels, which is a very secure thing, but it doesn't tell you where maybe the packet is dropping if you get an incident or if you've gone into a troubleshooting session. Thousand Eyes helps you with this. This is now coming into the newer versions of vManage because Thousand Eyes and the Catalyst SD-WAN manager are merging together very nicely. And we have this, like what I showed you before, like all of this application stuff, the circuit stuff, that's actually Thousand Eyes under the hood. So this is all powered by Thousand Eyes, and then you get things like predictive networking. Unfortunately, since this is a dev instance, it doesn't give us like this. We don't have this activated here. But basically, with this predictive path recommendation, what it would do, it would tell you, okay, for example, for all your WebEx traffic, it would be better if the policy were to change. And in recent versions, you can change the policy for WebEx traffic, for example, via API. So this is something that we're currently testing. That once there is a significant path improvement, if a device takes if like the packets from one side takes one service, like one circuit or the other, it would apply this via the API. So that's definitely going to improve the quality and the experience for the users at our sites who are the employees. And then Splunk, similar to what Dan and Jerry shared, we are using Splunk heavily for all of our syslogs. So all of our syslogs are now going straight there. They can go from vManage to Splunk or from our devices to Splunk. And then all of our automation, all of their logs, all of the internal APIs that we've got, all of the internal applications that we've got, they're also going to Splunk. So this is, for example, from the syslog example. So this is a syslog message from a certain device that tells you that EIGRP has gone down. And this is what's going on. This helps our engineers who are on call, our operational engineers, to then, it's easier for them to understand the timelines. And we're looking at making sure that, we're creating dashboards and making this easier and easier for them. So they would be able to just go to Splunk and get all the entire timeline for a particular device. And another thing, that's where what I was sharing before about the APIs and the calls. So for example, we have a lot of software going on. We have a lot of teams doing automation right now. So across Cisco IT, we're now trying to make sure that all of these logs, they go straight to Splunk. So then we would easily troubleshoot any issues that we see. And that's even coming from sources like Meraki, for example, vManage, Catalyst Center, so on and so forth. And yep, that's it for me.
Awesome. Thank you so much, Motaz. I think we should definitely acknowledge your time zone right now, if you mind telling the group where you're calling us from.
Yeah, so I'm based in London in the UK. So it's 8:30 p.m. now.
So yeah, thank you so much for taking the time to walk us through all of that. Doesn't look like we have any questions in the chat, but it was very well attended. So thank you all. We'll send out the recording and the slides for this. And if you have any questions afterwards, feel free to reach out to us and we will get those answered for you. Thanks, everyone. Appreciate your time.
Thank you.
Thanks for the opportunity.
Everyone.
Thank you.